In this presentation, we're going to go ahead and look at how we can apply the methods discussed in the Introduction to Efficient 3D Machining to an STL file that we're going to import of a guitar bass. So first of all, let's go ahead and create ourselves a new job, and we're just going to specify some dimensions. So I'm going to have a 20-inch width, I'm going to have a height of 15 inches, and the thickness is going to be 2.5 inches. We're going to be working in the lower left, and we're just going to go ahead and press OK now. So the first thing that we're going to want to do is import our STL model. So that means we're going to have to go to the modeling tab, and then we're going to go ahead and select this option here which says import a component or 3D model. So just click on that and then just navigate to the guitar file, and you'll see that it's called guitar.stl. And then highlight that and click open, and you should then be presented with this screen here, which allows us to orientate our 3D model. So this is our 3D model of our guitar bass. The red wireframe represents our material size, and the flat rectangle here represents our zero plane and where our position of the model is on that zero plane. So the first thing that we're going to want to do is change the orientation of this 3D model. So we want to have the back of the guitar against the bottom of the surface. So if we change this initial orientation to back, you should see that then the back of the guitar bass is now flat on the zero plane, which is where we want it. The next option in the list is the rotation about the z-axis. Now you can see at the moment, for this to be orientated the correct way, we need to rotate this 3D model 90 degrees to the left around the axis it's currently on. So if we just choose the -90 option there, you'll see that we are now orientated correctly. The next thing that we need to do is just change the size of the model. So if we lock the XYZ ratio, I'm just going to change the width of our model from 43 inches to 18, like so, and then click apply. And then we can just click the center model as well, and you'll see that's then centered perfectly within our wireframe representation of our material setup. The last thing we need to do before we can apply this and import this into the job, just highlight that file and then click open, and then we will be presented with the Orientate 3D model form. And this is where we can change the orientation and the size of the model before we import it into the job. So as you can see, this is our 3D model. This red wireframe at the bottom represents our material size, and what we need to do is orientate this and fit this inside this red wireframe. So first of all, we want this back of the guitar to be flat against this zero plane here, which is this flat rectangle as you can see at the bottom here. So in the initial orientation on the left hand side, just simply change the radio button to from top to back, like so, and that'll then rest the back against the top of the zero plane, like you can see here. Then we can go about rotating this model around the axis to actually match the orientation of our material block. So this needs to just be turned 90 degrees to the left. So I'm just going to go ahead and choose this -90 degrees option here. As you can see, that's now changed it to the right orientation as the material. All we need to do now is just resize the model and then position it in the center of our material. So first of all, let's go to the model size section. Let's make sure the lock X, Y, and Z ratio is checked, and just change the X dimension to be 18. Click apply, and then press this button here to center the model, and that will center the model within our material workspace. And the last option here is the zero plane position in the model. So we want to have the whole of this 3D model in our job. So what we need to do is push this right to the bottom, so that as you can see now the guitar sits right above the zero plane, which represents virtually our bottom of our material. So if I just go ahead now and scroll down and click OK, you'll see that that whole 3D model will now be imported into Aspire. Now with the new version 8 software, this can also be imported into VCarve Desktop and VCarve Pro. So the first thing we're going to do, as it's a 3D model, we're going to add some 3D toolpaths to that. So let's go ahead and go over to the Toolpath tab. And the first thing we should always do before we go ahead and machine anything or calculate any toolpaths is to set up our material. So as you can see, we've got a thickness of material of 2.5 inches. We're working from the lower left in the XY data position, and we can set ourselves a gap above the material to start from. So I'm just going to type in 0.03 there, and then we can go ahead and make sure the rapid Z gaps and home start position are all acceptable for our machine if we do plan on running this, and then press OK. And the first toolpath I'm going to create is a 3D roughing toolpath. So I'm going to go ahead and select that, and then I'm going to go ahead and select my 3D roughing tool. So I'm going to go into the tool database, and I'm going to choose the 1/2 inch end mill tool. Just make sure the feeds and speeds and cutting parameters are all okay for your machine if you do plan on running this, and then press OK on that. And then I'm just going to go ahead and select the model boundary as the machining limit boundary for this. Specify how much machining allowance you want to leave on, so I'm just going to specify to leave on 0.03 of an inch. Keep the roughing strategy as that. I'm just going to scroll down and go and press the calculate button. And let's see what we've been left with. So you can see that we've gone ahead and we've roughed away the majority of the pickup slots and the neck. Now, because we've used such a large tool, and if you remember our step down when we were looking at the parameters was 0.4 of an inch. So that is why we haven't actually roughed out any part of the other shape of the guitar base. Now, if you wanted to still use the 1/2 inch tool to hog away the majority of the material quicker, but have it so it steps down further and actually roughs away some of the actual shape of the guitar base, all we would need to do is go into the toolpath by double clicking the name, and then click edit to change the path depth. So I'm just going to change this to around about 0.2. Now we can actually kind of get a rough idea of the Z depth that we need to get if we just cancel this, and we just look down the bottom right here and just check out what the Z depth is of when we go here. So you see that's about 0.27 of an inch. So if I just go ahead and put 0.2 in the path depth, that'll then rough out the material that's around that area. So if I just type in 0.2 there and press OK. Now this is only going to edit the tool parameters temporarily, just for this toolpath only, because we've used the edit button, not the actual select from the tool database. So let's just go ahead and recalculate that, and you'll see that we've now got more area where the actual roughing path is going to machine away for us, like so. So now we've got our roughing paths, we can go ahead and create our finishing paths. So I'm just going to go into the 3D finishing toolpath icon by selecting that one there. And I'm going to choose my tool from the tool database, which is going to be a 1/4 inch ball nose tool. Check the speeds and feeds of the tool, make sure they're all appropriate for your machine, and then press OK. And I'm just going to choose the machine limit boundary to be model boundary, like so. And I'm going to specify a slight boundary offset, just so that the roundness of the tool does slightly creep over the edge of our model, but doesn't actually go all the way down at the bottom of the material. So I'm going to choose a 0.03 boundary offset, and then click calculate, and then we should be able to preview our 3D finish. Like so. So if we just go sideways, you'll see that the tool hasn't actually crept around the edge, which is exactly what we wanted. So if we just go ahead and preview that toolpath, you'll see that this is what we have been left with. Now, as you can see on first inspection, we are missing a few holes. Now, if we just zoom in a little there, you'll see that even the holes that it has done aren't even perfectly round, and they are unfinished, like so. And especially these ones here, the tool hasn't even gone into the actual material. And then the last toolpath that we'd need to create is our cutout path. So let's close the preview toolpath form and create the profile toolpath. Now, I'm going to need to create a vector for this, so I can quickly get open this tab. Now, while it's still selected, all I need to do is press the create vector boundary from the selected components, which it is selected. Select that, go back over to the toolpath tab, and in the 2D view, you'll see that now we have got ourselves a vector which we can use for our cutout paths. Now, you'll see it's also created vectors around these circles as well. So what we need to do, as you can see at the minute, is a solid pink color, which means they are grouped. If we just press the U button on the keyboard, you'll see that they're now ungrouped. So I can just go ahead and delete these excess vectors and just select the vector that I want for the cutout. Type in Z equals on that. Use a large end mill tool, so I'm going to use a 1/2 inch end mill there. I'm going to go around the outside and I'm going to calculate that toolpath and then run the toolpath. And then if we double click the excess material on here, which would be this area here, that will then get rid of that material for us. So we can actually then inspect our preview. So it all looks good, apart from the fact that we've got the holes that are unfinished. And you can, if you look at the surface on the Z level here, you'll see that it's all uneven as well. So that's also going to need hand finishing to smooth that out as well, to make it a flat, smooth surface. So, using the method that we discussed in the introduction to efficient 3D machining, we can now think about how we could machine this guitar bass more efficiently, to not only cut this faster on the machine, but also to have a smoother finish. Now if we look at the moment in the summary toolpaths, this is going to take 3 hours and 8 minutes, so 60 minutes roughing, 2 hours and 50 cutting the actual 3D product, and then 4 minutes cutting the actual product out of the material. So how can we improve this? Now, using the methods that we discussed, what we could do is we could create vector boundaries around all these different areas to then allow us to utilize 2D and 2.5D toolpaths. So we need to vector fit around these pickups and the neck, and also create holes as well for the volume knobs. Now if you happen to have designed this in an external CAD program, you can also import vectors that you use to create this 3D model into the software as well. But if you haven't, you can use a few tools within the software to go ahead and create your own. So let's go into the drawing tab to start with and go into the 2D view. And what we can do is we can start to create ourselves some vectors. So the outline has been done already for us. Now we can also get a few others for free. So if I just delete that and start again and just select our actual component and then use the create vector boundary from selected components, you'll see that as we had previously, we also have the vectors for our circles, which will be for our volume knobs. Now as you can see, if I zoom in on close inspection, these aren't anywhere near circular. So these would really be of no use to us. But if we were creating this to actually create ourselves a guitar bass for our own components to actually plug into this guitar bass, we should know the diameter of the circles that we need. So we could literally just go ahead, delete these, and then recreate them using the Create Vectors Draw Circle tool, and just literally go ahead and place a circle in there if we knew the exact diameter of those that we needed. And then we could also use the Draw Vectors tools to go around these shapes here for the pickups and the neck. Now I'm not going to go ahead and actually draw these. I'm going to go ahead and import some that I've already created. So in the file operations, you'll see there's an import vectors from a file option. Just go in there and then highlight the guitar.eps and then press open, and this is then going to import some vectors that I've already created into the software. So let's take a look closer at the vectors that we've created. So you'll see that the circles have been created at this exact width down here, as you can see, and these are all the same. So these are the exact same diameter as the volume knobs that I plan on inserting into my guitar bass. Then you can see that I've got these vectors that I've created around the pickup slots. Now these have also been created using the hardware that I plan on inserting into these places of the guitar. And also I've created myself a separate vector here for the neck as well. Now you'll see that I have got a couple of vectors for the outer area of the guitar. Now these are purposely created for the different types of toolpaths that I plan on creating with them. So this inner vector that I've created, that I've got highlighted at the moment, is for our cutout path. So we're going to use a profile toolpath to cut out the guitar bass, and this outer vector, which you'll see that runs into the actual neck base, is for our 3D finishing toolpath. And I've created it with a slight offset around the outside of the guitar, so it's just enough to allow the ball nose tool to go around the 3D shape to give us curvature going down the side of our guitar, but not enough so that the tool will then plunge all the way down to the bottom of the material. So now we've got our vectors, let's go ahead and create some toolpaths. So I'm going to hit F on the keyboard to zoom to fit, and I'm going to hit this button here, which is going to send us over to the Toolpaths tab itself. So first of all, I'm going to go ahead and edit our roughing and finishing toolpaths with the new vectors that we've created. So I'm just going to double click on the roughing machining, and I'm going to go ahead and select the vectors that we need to rough. So first of all, I'm just going to go ahead and select all. And then what I'm going to do is I'm going to hold shift and then deselect the vectors that I don't need. So first of all, I'm going to deselect this neck vector here, and then I'm going to deselect the inner vector of the guitar shape, and those are the vectors that I need for roughing. So all I should need to do now is change my machining limit boundary to the selective vectors, like so. I don't need to add a boundary offset, as these vectors have been offset already. And I can add a machining allowance, keep that the same, and all I should do is recalculate that toolpath. So if I reset the preview, you'll see that now our roughing is not going to go into any of the holes, nor is it going to go into any of the pickups or the neck. And then we can go ahead and recalculate the finishing toolpath. So I'm just going to go back into the finishing toolpath. I'm going to make sure all those vectors are still selected, which they are. And all I need to do again is just change that machining limit boundary to the selective vectors, but this time remove the boundary offset and then calculate. And then all we should need to do is just preview that toolpath, and this will then leave us the areas where we actually need to go ahead and create ourselves the 2D toolpaths. So if I just go ahead and run the cutout, that'll just give us a bit more of an idea as to what we've got left. I'm just going to double click that waste material. So now we need to go ahead and create some toolpaths for the pickups, the neck, and these holes as well. So to start with, I'm just going to go ahead and close the preview toolpaths form. And what I'm going to do is I'm going to first of all create these holes for our guitar. So in the 2D view, I'm just going to go ahead and select these circles. So I'm just going to hold shift to select this last circle, and what I'm going to do, rather than use a drilling toolpath, as these are very specific circle sizes that I'm going to be cutting, I'm going to use the pocketing toolpath to actually create this circle for me, as I don't have a tool which is exactly the width that I need for the drill holes. So choose the pocketing toolpath and specify your cut depth. So I'm going to cut down to 1 inch, and I'm going to specify my tool to be a 1/4 inch end mill tool. Make sure the speeds and feeds are all applicable for your machine. And I'm not going to use the large area clearance tool this time, and we're going to use an offset strategy, so it's going to start from the center and then work its way out to the exact width that we need for those circles. And then we're going to go ahead and just call this pocket holes and then calculate that toolpath. So we can go ahead now and preview that and see exactly what we've achieved. So let's go ahead and preview. Now you'll see straight away, you can see we've got some nice circles, and they go down to the exact depth that we desire. And you can see that there's no need to be hand finishing any of those holes either. So next we can move on to creating some pockets for our pickups. So I'm just going to close the preview toolpath form, and I'm going to go into the 2D view and select my vectors for the pickups, like so. And I'm going to go back into the pocketing toolpath and specify my cut depth for those. Now I've measured the hardware. I need to go down just under 1 inch, so to 0.9. That's how deep my pickups are, and that's how deep they go into the guitar base itself. So all I need to do now is choose my desired tool. So I'm going to stick with the 1/4 inch end mill that I used for the previous pocketing toolpath, and the rest of the options should stay the same as well. And then all I need to do is go ahead and calculate that toolpath, like so. So if I just zoom in, you'll see when I preview that, we'll have some nice pocketed areas here for our pickups. Now the last toolpath that we need to create is for our neck base here. So if I just close the preview toolpath form, now I'm not actually sure how deep I need to actually cut my neck, but if I look in the bottom right hand corner here, where it gives me a readout of the exact coordinate and height of the pixels, if we just hover the mouse over the neck area, you'll see that the Z depth is minus 1.0984. So that's how deep we need our pocket for the neck to go. So what I'm going to do is I'm going to select the neck vector here, just highlight it like so, go into the pocketing toolpath, and if we go into the 3D view now, we should be able to just highlight the cut depth, hover our mouse over the area where we want to copy the Z depth from, and I'm just going to read it now from the bottom right. So I'm just going to type in 1.0984, and that's the exact depth that I need to cut to for my neck. So I'm going to keep the tool the same. I'm not going to use any large area clearance tool, and the rest of the things are going to be the same. I'm just going to change the name to this to be pocket neck, and then calculate that toolpath like so. And by doing this, we should have shaved off some of the 3D machining time. We're also going to massively improve the cut of these pockets and the holes. So we're going to end up with a lot less hand finishing to the base of the guitar itself, and we should have reduced machining time. So let's go ahead and close the preview toolpath form and just see if we have saved any time. So I'm just going to go to the summary of all toolpaths. Now in this example, we've only shaved off around about 6 minutes in machining time itself. But however, what you have to think about is the quality of finish that we're going to get from these 2D toolpaths, from the pocketing and the holes, is going to be much greater than that would have been created using the 3D roughing and finishing toolpaths alone. And the fact that we also had incomplete holes for our volume knobs as well. So even if this method has no immediate time savings, it does have its benefits outside of the machine as well. So let's go ahead and take a look at a comparison table between the two. So this table just demonstrates where the difference between full 3D machining and then machining only the parts in 3D that we need to versus the 2D toolpaths for the holes and the pickups and the neck. So you can see the total time is virtually the same, so it's about 3 hours and 10 minutes. The major difference between the two is the fact that we had holes which were incomplete on the full 3D machining model. The surface on both of these is going to need a good hand finish just to make sure it's nice and even and smooth. But also the pockets at the bottom of each of these pickups and the neck is also going to have a radius that runs around the edge of the pocket due to the fact that this would have been done with a ball nose tool. So that can prove quite tricky to hand finish that as well. So there are a lot of benefits into machining 3D more efficiently using vector boundaries and then using 2D and 2.5D toolpaths. But whereas in the Rose and Crown demonstration, it was quite obvious to see how much time we can save machining with that demo. But with this demonstration, you can see that we don't really save that much time with machining on the CNC, but what we do save on is the fact that there's a lot of finishing to do on the full 3D machining model that would be required after it actually comes off the CNC machine itself. So it does show you, it does benefit you in two completely different ways. We obviously just need to balance the time we can spend trying to improve our 3D machining methods to actually just 3D machining it in the first place.